Zero to hero. What does that mean? Maybe that's a very corny title. How do you make a hero? What is a hero? It's the guy that deploys at 5 o'clock on a Friday and keeps you all weekend. That's not quite the hero. But we're not going to be talking about deployments. We're going to be talking about things that make you particularly efficient in Go, things that we do at Luno that really ramp up people. I think one of the biggest contexts or things is that we need to start with what does a Luno do? But first, context, always. Just remember that. That's a little like nugget. There we go. So what is Luno? Well, we make investing in cryptocurrency simple and secure for everyone. It's kind of small for you at the back, but it says not including baddies. So that is a legal term for anybody that is, it's not a legal term. Come on, don't be serious. But for anyone around the world, so obviously we don't want to be an on-ramp for anyone with malicious intent, but we want to make it simple, secure, safe, and just something like a common brand, you know, just as much as you know, maybe not Lloyd's or HSBC or anything like that, but something that, you know, you think of and you're like, oh yeah, I really want to go with that brand. I trust them. I trust that they can have my money and handle it and be kind of that broker for me. Into the crypto world, we want to make it simple. You don't need to know a lot about crypto, but you can buy and get involved. So we've got over 10 million customers around the world. I mean, there are obviously some countries we're not available in, but that's largely due to sanctions on them. So, obviously, we're not being sanctioned, people. Come on. Cool. But who are you? Well, that's a good point. So I'm a software engineer at Luno. Some weird things about me. I didn't study engineering or anything like that. I studied psychology. And then it kind of makes the second part a little bit more real. I accidentally got my first job as a programmer. How? I can talk to you afterwards about it. But it's just that weird thing. I didn't really know I was applying, and next minute I had an offer, and I was like, okay, let's go with it. I joined Luno as a front-end web engineer, working with Angular, and over the course of a year, I was like, I want to work with Go. Go is an incredible language, and I mean, come on. I mean, it is such a nice, simple, and just, it makes you want to write code. So, switched over to the back end. I had to really convince a few people that I could do it, but I did it. And what makes a Go hero? Well, these are a few things that we have been working on at Luno. It's very tough. Let me just move this down. Can you hear me at the back? Sorry about that. Okay, cool. So it's really tough to hire in, Go engineers. We are relatively a small industry of, software engineering and development. So Luno doesn't just hire Go engineers. We don't just say, cool, you got Go experience or you got this kind of experience. We say, let's look at your problem-solving abilities and let's see if you're a good fit for the culture. And so the big thing is we take on the responsibility to level you up in terms of your skills and your knowledge of Go and a few other elements. So we take on this responsibility and we start off with toys. You arrive at Luno and you're playing with toys, first thing, not real toys. So it's a little bit, but it's fun. So we have this thing where we want you to become familiar with a few elements. We want you to become familiar with gRPC. We want you to become familiar with our service architecture. So how do we structure our services? File, directory, monorepo, just split up repos. And we get you familiar with all those different elements. We get you familiar with state machines. Well, at least the way that we're using state machines in our event-driven architecture. We have our own kind of open source tool that we built called Reflex that handles that producer-consumer model of events. And you kind of learn to interact with that. You learn how to, consume events and generate events. You learn how the state machines work and how to design one. It's quite fun. You learn, if you've never used Go Generate, we use a ton of it. So you quickly become very familiar with that. And also database changes. How do you get something into our staging environment or a production environment? So how do we go through all of that? So this is my attempt at working with Illustrator. I didn't create those. There's mostly assets. As you can tell, I'm a software engineer, not a designer or illustrator. But over here, you have your service. So you're going to be creating something over here, right? And let me first explain. What are these tall buildings? So we have this thing where we have what we call a physical service and a logical service. So a physical service is the actual Docker container, that actual image, that one binary with, a port, with an address and a port and everything. And so we have two of these. But the way that we write our code is that we write it in logical services. So they don't have to be deployed all independently, but they can be deployed together. And then if we find a reason that this thing needs to scale by itself, we can literally drag it, drop it, give it its new main.go file, point other services to the new one, and then that's it. No rewriting, that's it. So what you've got over here is these logical services. So they take over different logical concerns. And so what we've got here is we've got a customer, we've got a supplier, and we've got a worker. So your first interaction is this is pre-built, you don't have to do anything there. And you are going to just be writing a service. And what is that service going to do? It's going to create toys. So what is the first step in doing that? You can see the little white dot. You guys, everyone at the back might not, but I worked pretty hard on that one. So customer requests a toy. So as you can see, I will wait for the GIF to start again. There we go. It starts off with customer, and it does a little trip all the way over to your service. And what is that trip? It says, hey, my customer ID is this. Please make me a toy. And your service, just by the way, is not just making toys. It's a toy. So I get the joy of seeing what people come up with. C3PO, it's a very hard name to read, but it's a service. And are you a bicycle? Are you this? Are you that? But you create a service under a single toy's name, and that's all you make, right? So you've got this thing where customer sends you a request over gRPC. So here you're getting familiar with gRPC already, because you're going to have to create those methods, create the, the protos and generate it, and implement that gRPC server and the client. And so the next step is for your service to say, okay, cool. I've got that request. Now I need to go get the supplies. So it does a little trip all the way over to that next physical service and interacts with that logical. And that is the supplies service, supplier. Gets the supplies for the toy, for the toy that you're making. And the very next step is to do a next call to the worker service. So it needs some workers to put this thing together. Your service doesn't know how to construct it, so it relies on this workforce. What's fun is that randomly this service will error and say we're out for lunch or we're protesting today. So you have to kind of handle that one, just like the train delays at the moment. So at the very end, your service will do a call back to the customer service, and that is the entire kind of flow. Now the thing is, that seems very simple. You do one call, then another, then another, then another. But these are all asynchronous processes. We're using a state machine to modify this request and keeping track of it. It also needs to be idempotent. So you cannot reprocess it if it's moved on, if another consumer has gone and consumed this event, done the work and updated it, you can't keep doing that. You don't want to collect supplies over and over and over. You want to do it once, and then you want to go and use the workers once. Then you want to deliver the toy once. You don't want to deliver a toy that's been already delivered. So this idea kind of is a fun and playful way to interact with how we deal with, maybe it's an integration with our identity provider for onboarding, or maybe transactions, or dealing with any of those complex elements in an asynchronous way, but we also try and keep it highly readable. So we also go and dive into Learning Go. Why did I go and not do some books? Well, I think Learning Go is a little bit like music. You kind of get a smooth rhythm, and as you kind of gain more experience, you become more comfortable with it, and it just starts flowing. And it becomes quite a beautiful thing when you write Go, and it just kind of, you can sit there and after, some time, you just write something on, and you're like, wow, that was effortless. And then you realize, that's horrible. Let me start again. And just like musicians, you'll keep going over and over and reworking it and finessing it. So what do we do about Learning Go? For those engineers that have never interacted with it, there's a lot of complexities sometimes, maybe hidden, abstracted away. But we kind of go over a few things, right? So these are the areas. So we start with the gotchas. The gotchas, well, there's a few things that you kind of would expect, and then they don't really happen the way you expect them to, and they can cause some issues. And they can have you scratching your head for a few moments. There's also some gray areas in Go, which is kind of weird. But even from the beginning days, there's been some gray areas. Which way do we go? Which way to do that? And a good example of this is variable initializing. Initializing a variable, the way you construct a variable, you can do it quite a few different ways. I remember Rob Pike in a talk said that was one of their bigger regrets, is how many different ways you can do that. And so we start clarifying, let's go and do it like this. Not because that's the right way, but because it's way more efficient for the entire company or the entire team to be doing things in the same working order. So you don't have, oh, well, this person's doing it this way, this person's doing it this way, and then it's just hard to gauge what's really going on. The readability just becomes increasingly simple if you have similar patterns. If you want to initialize zero-value variables the exact same way, So let's jump into the gotchas. This is going to a little bit of a feedback point. So I would like to ask, maybe nobody wants to do this, but so here we have an example. We initialize x and assign it a value of 1. We print it. Then we say if true, which who thinks that's not going to happen in this case? Okay, cool. And then we're going to print it again. I don't know why, but we're doing it. And then we say, cool, x must be 2 now. And then we print it. And then outside of that if statement, we say print x. So is there any ideas of what we're going to see here?
Compiler error, because you're reinitializing x.
Sorry?
Compiler error.
Compiler error?
Yeah, in x, because you're...
That's a good thought. Yes?
1, 1, 2,
1,
1.
1, 2, 1. Indeed. So, where's this clicker? There we go. So we print 1, 1, 2, 1. So there's no compiler error, but it's called variable shadowing. So what happens here is you actually, within that scope, you're redefining what that is. And once you leave that scope, it no longer exists. So the original value of 1, this is the fix actually. The initial value of 1 is still printed. The way to change it is by not declaring that there's something new within that scope, but referencing something outside of that scope and changing its value. This is something small. The compiler won't pick it up, but you might assume that it works fine. Now, there's a good point that testing should cover this, and it will, but it's always nice to know so you don't spend that time kind of figuring it all out. And especially when you're not trying to print 1s and 2s, it saves you a little bit more time, especially in testing. Okay. Does anyone see anything weird with this? Any hands? Anyone can even shout out what they expect will happen? Am I in the way? Sorry? Panic. Indeed. I just realized that I'm not consistent with my colors. But you guys realize it'll panic. So, why is it going to panic? Well, that is the variable of x. Sure, it's going to be a map, but the value is going to be null, right? So you're trying to insert something into something that's null. It's going to panic. It doesn't happen. There's a few ways that you need to construct maps. So one way is using make, and so that will actually construct it and initialize it nicely. Or if you want to go with an initial value and do it more like a literal and then modify, you can do it without make, but providing some initial values. And that will not panic. Right, okay, so let's go into pointers. Who loves pointers? People are smiling, but they don't want to put up their hand. They're like, not even me. Okay, so foo, bar, car. Okay, first of all, let's start with foo. We've got t and its pointer of int that we're going to be passing in. The indentation on the slides is weird. That's not how the linters would help me out there, but anyway. Cool, so j is 101. Then we're going to have t, and we're going to be like, whatever we're doing there, we're going to be trying to reassign the address there. So we're going to take the address of j, and we're going to give it to t. Cool. Then we've got bar. Okay, what's happening here? Same thing's happening in terms of the parameters. We're passing a pointer, t, type int. We're constructing k and initializing with a value of 102, and then we are redirecting the value. So we're saying this pointer must point to a different value, different reference. And then car, well, car is doing something very silly where it's just changing the input, the parameter. It's not really doing anything. No pointer. So, what do you think we're going to be getting with this example? Any ideas? It's getting quieter. Maybe I should throw more loafers out. It's like feeding. Okay, so any ideas? 101, 102. 102. So this is what we get. We've got 3 options. Let me jump with this. So we're starting with 100, right? So we're going to start printing up there. And who thinks it'll be the first top one over there? Hands up, the top. Sorry, can you put them up? Okay, great. And then in the middle one, so it's 100, 102, 101, 102, 103. Hands up. Okay. And hands up for the bottom one, 100, 100, 102, 102. Ah. And who thinks of the fourth option that's not here? Everybody. Oh, there we go. Thank you. Cool. Well, we have 100, 100, 102, 102. Is anyone scratching their heads? Is anyone curious why? Yeah, right? I mean, can you imagine this went to production on a Friday? That's not the time you want to be enjoying this moment. So, what happens? Well, so in foo, forgive the indentation, so the T that gets passed in is a copy, right? So Go actually goes and makes that thing a copy, and then when you want to change the pointer, it changes the copy. So to be honest, you're not really doing anything. But when you're passing in a copy, it changes the underlying reference, which is not being part of the copy. And so that's why when you assign the actual value and says, all right, this must now point to this new reference, or this new value, it actually modifies it. And then car doesn't modify anything because it's not a pointer, it's not returning it, it modifies it, but it ends within that scope. And so does that make a little bit more sense? Yeah? Okay, I guess I got to work harder on that one. Let's get into some gray areas. So, gray areas, variable declaration. So with variable declaration, it gets quite fun because none of these are wrong. There is nothing that says that they're wrong. But you can imagine a large code base of maybe 100 engineers, 200 engineers, 500 engineers. If you're kind of doing all these different patterns, it becomes like, well, what are we doing? And it becomes a little bit more complicated with different types and maybe maps and this and that to constantly say, yeah, this is a little bit more readable than the other. So at Luno, we decided, let's make some decisions and let's be consistent with it. Because consistency definitely helps our readability. So we decided, let's go, if it's going to be a zero value that you want, just do a variable declaration. Just a declaration, that's it. No initializing value, nothing like that. It's also a little bit easier to read than having the syntax of N64 wrapped around a zero, making sure that it's not an int. Also, doing the declaration with the initialization, we just said, if it's going to be a zero value, do that. If you don't want it to be a zero value, then sure, go ahead and do those things. It's fine. But when it comes to zero values, there's really no point. So why leave it open-ended? It also helps engineers kind of not sit there like, which one should I do? Maybe you won't be like doing that for very long. But it is definitely a nice way, and it kind of gives a little bit more confidence to the engineer about what they should be doing, and makes things a little bit more speedy, especially coming from another language where maybe there was just open-ended and you're so used to it, and now you just want a little bit of direction, you can move on the basic stuff. Parameter sequencing. That's another one that's kind of an interesting one. So we at Luno, we like to have consistency, predictability, and together that kind of makes readability. So over here we've got two examples of basically some functions, and they've got different sequencing. So in the original one at the top, we've got our user ID in the similar position, and we have context in the same position. Always first, then we have our user ID in the second position, and then over here we have entries at the end. You know, that's where it starts differing. It's starting to do different things. But over here, if you had to deal with some functions where user ID is getting passed in at the end, or maybe it's halfway through, you're going to have to be relying on your IntelliSense, or maybe going and following the function and see where that declaration is, look at the signature. Where do I put this? Or what is expected in what order? So it's also a lot easier to remember. If you use that function before, you quickly remember, well, I just pass in context, I pass in the user ID, and then the entries, because I'm calculating. Or maybe I just don't need that. But you know it's always, if most of your functions use a user ID or some other foreign ID that you want to use, context, you can almost just start writing, and you can figure out what the rest of the parameters is. So over here, wow, that shifted, is the user ID, and then here you can see it at the end, and then at the top, forgive the shift, is the user IDs being in a similar position and being predictable. Pure functions. Well, Go is not really object-oriented, although I guess many people can use it in that way. But avoiding doing multiple things in one function is a great idea, even if you want to do it as a method. But pure functions are gold. They're going to make your life easier for writing tests. You can also, it's easier to read. You don't need to go and say, oh, let's do all this mumbo-jumbo in one big function. Let's split it up to a couple of pure functions, maybe something that's going to call all of those and put them together. So here's an example. Another thing is manipulating state of something under the hood. It's really horrible in readability, really hard to debug, because especially if it's like a map and modifying a map under the hood, you might not use it correctly and you might not actually modify or add that value that you want. So at the top, we've got a thing that's going to do balance. I've called them different function names because I felt that was more readable. So here you're passing in entries, and it gives you a balance. Here, you're going to try and calculate something. So here we're passing in like a balance struct and a pointer to it so we can modify it. But then we've got all the entries coming in, and as you can tell, the sequencing is at least aligned. But it's a little bit harder to follow. What's going to be happening under the hood? When you call this, there's no return, so, is it really happening? Is it really happening? It's a lot easier if you can maybe just have a pure function, returns a value, and you can name that something meaningful. So, free functions over methods. In Go, a lot of people come from an object-oriented background, and we see it a lot at Luno, where people come in and immediately it's like, oh, I can create a struct. Oh, I can add some these methods onto it. It's just like a class, woohoo! And it's like, well, it doesn't really work the same, but it makes you happy. But so we don't do that, even though it makes some people happy. It makes them sad now. So what we do is we say, well, what would be better is let's take that function, that example from previous year, and we say, here's the balance. We've got our context, we've got our user, we've got our entries. Let's get our balance. And then if you have a method on a user type called balance, but it's not used in the context where you would always use user, it kind of just doesn't fit. It's kind of, overused. And you're not really leaning on pure functions or any kind of logic. You're kind of implementing all your business logic onto a type that's not always relevant. So now when somebody wants to use that, how are they going to find what they can potentially use? It's not always in the expected place, or it's this long list of what your IDE will kind of compile as suggestions of what to do. And then it just looks like a very cluttered API. And that becomes very hard to read, understand, and use. So sometimes it's okay. Genuinely, methods aren't bad, but you've got to be intentional about it, right? You don't just want to chuck a method on. Oh, I need this little bit of logic, and it's going to use your parameters. It's not that hard. But if you've got maybe a user object that's got first, middle, last name, and you want to put them together, well, you don't really need a pure function for that. You can, but if it's going to be imported, that type, and a lot of people are going to be using it, you don't have to get them scratching their heads figuring out where you put that function. You can add it as a method. It's fine. Maybe if it's trying to implement an interface around calculating area, or maybe it's just you want that function always there. Area is a nice one. 2 kilometers, conversions. Keeping the context of the object, the methods have to relate to it almost in a lot of the situations. You've got to justify it. Rather have a pure function and move it to a method if almost everyone that is using this object or this struct is using it. And it often can clean it up and have a nice, lean API. No-goes. Well, maybe some of these can be argumentative, but we have some no-goes. We decide, let's not do this. This is not nice. So what are they? Using a zero value as a meaningful enum. What are you talking about? Well, maybe it's considered weird. Enums have zero value, so if you construct it like this, we have unknown, at the bottom, we say apple is of type example, and its value is 0. And that's cool. We can identify it when it's type 0. But as we know, the underlying value is an int. So if you try and look something up in a database, it's not found. Maybe you don't even want to handle that error. You should always. But maybe it's a unique case where you just want to pass back an apple. You can't tell the difference between it doesn't exist and apple. So you're dealing with a lot of apples, and you're becoming an apple farmer very quickly, and it can be very complex when you're like, why are we doing this thing? I'm not intending it. It's not supposed to be. And then you look, oh, because also, if you're not defining it very explicitly, zero values are just returned. So you can very easily find yourself in a situation where you're dealing with apples, but really you are not trying to deal with anything of value there. You should probably be throwing an error. So what we do is we always define a zero value as unknown. sometimes we have a method on this type, and we say, what is the valid ranges? We even use a sentinel value. So we can say, okay, between 0 and our sentinel, or our unknown and our sentinel, those are valid ranges. As people add it, that kind of shifts along, and we know what's a valid entry or type. So you can look it up. You can say, is this valid? No, somebody's chucked in a random number in the database, tries to wreck everything, just ignore it. So that has been a lifesaver to me. Nil checks. Well, I don't know how many people, it's almost like habit sometimes to just keep checking. Doing this super defensive coding and not having a little bit more confidence of what should happen. So the one thing that we have is we don't allow null checks. Now, it's a little bit complicated when it comes to configuring things, maybe some configuration input. There can be some circumstances. But we really make, in an MR, the intention to say, but why? Why do you need it? Please, let's talk about why and try and gauge. And more often than not, it's not needed. So doing this is we're checking that there's no error. And then we're checking that if the value is null, or maybe if the value is not null, then do something. But if you're returning null and null, so the error has to be null, and the value has to be null, what is going on? We're not really using errors correctly. So what we will do is we'll always define, okay, if I don't want to return a value, I'm going to return an error. I'll define what is wrong. I'll use an error as a value and as a descriptor of what exactly has gone wrong. And what's nice is that we also add some tracing to it so we can have some information as to what happens. And so these sentinel errors or exposed errors that we have that kind of come through these functions, we can handle them. So we say, okay, let's say we want to run, and the error is not the right operating system, like we can't run. Or I don't know, something like workers are on strike today. We can say, okay, let's handle that. If it's this error, let's do something. And that's a lot better than saying, cool, the error is null, but the value is null, then let's figure out this. It's kind of still ambiguous. And writing an explicit error is very helpful, especially when there's multiple circumstances that you want to handle. Go to. I honestly would love to ask who loves GoTo, who's used GoTo. I haven't. I don't want to ask because then maybe people will feel bad. But I don't think there's anything necessarily wrong with it. I just personally do not like it. And luckily, I'm at a company that doesn't seem to like it either, so yay. So GoTo, I've never really found a really good use case, not from what I've been working on. Maybe you do. But once again, it comes back to that conversation amongst engineers, working together and figuring out, do we really need this? Can we write it in a more readable way? If you've got a new engineer jumping in and they're like, go to my weird place. Okay, I'm going to go to my weird place. And then they think, okay, well, I'm going to go to it and come back. It's like, but it never comes back. And now you've got a problem. Because now you're one engineer, but maybe doesn't understand it all too well, or think, no, we're going to execute that last line. We're going to commit the transaction. We're going to do this. We're going to do something that you really depend on. And now all of a sudden, you've got an issue that you're dealing with on a late Friday evening. So here, in this example, we'll go from 1, go to our weird place, and print 3. And we're done. IOTA. Nothing wrong with you using IOTA. Please don't stab me or kill me or anything. There is a camera, so please don't. But IOTA can be troublesome, especially if you're storing that value, especially if you're passing or adding into your logs and there's a value change very quickly. So what you'll see here is you use IOTA and then you see apple, grapes, banana, kiwi. It really gets complex when the list gets long, right? As you can see, we jump from value 1, value 2, up to 15, 16, maybe it's like 103, 104. Now, you have this great job. You get this issue that comes in and says, hey, we've got a bug. And the value in the database is 412. Can you please determine what type that is? And you got to count on your screen, because it's IOTA, 1, 2, 3, 4, or you got to like reformat, use line numbers, this and that. When it's sometimes just a little bit easier to take the extra effort and have it explicit. Also, sometimes if the ordering or value changes, you can easily miss that in an MR. And if you change that, now all of a sudden your database and your logic is just not going to line up. Because your database thinks it's apples, and your service thinks it's bananas. And this whole scenario becomes bananas. And that's it. Thank you.